All right, we're going to be doing 9.1.3 Algebra 1. What is a polynomial? I actually recorded this video and my sound didn't work, so I'm actually going to be talking over all this stuff. So it may be a little bit off. So we're going to have the checkup, we have the study. We are going to, I guess, first talk about the first definition here. On the left side of the study is degree, the value of the greatest exponent in a polynomial. So the exponent is that number that is kind of raised above the variable, and the highest one in a polynomial is your degree. A polynomial has a couple different options. Let's kind of talk about that there. All right, now parts of a polynomial. Now they're talking about a monomial here, and we'll get to that here in a second. But the parts of like an individual term of a polynomial or just an individual monomial is that that number in front is my coefficient. It's multiplying the variable. It could be a number, it could be a variable itself, but it's in front of our independent variable and is multiplying. The degree is that exponent. So an exponent we call a degree. A degree is the highest exponent of a polynomial. And then the coefficient is the number in front multiplying. All right. Go over a little bit of what is a polynomial, what is not a polynomial. We'll focus on what is not. All right, so the first one's fine. The second one is not a polynomial because the exponent is a fraction. It's not an integer, so we cannot have fractional exponents. Our exponents must be non-negative integers, meaning positive integers. So the third one is fine. Now the fourth one is not because the variable is in the denominator. The variable has to be in the numerator. You can't have it in the denominator. All right, now there's a couple other examples I want to give you. We can't have a variable under the square root sign, so under a radical bar. We can't have that, so that would make it not a polynomial. And then we can't have negative exponents, right? So we need our exponents to be non-negative integers. So we can't have fractional exponents, we can't have variables in the denominator, can't have it under a radical, and we can't have negative exponents. I think I'm talking about monomial. So a monomial is just a polynomial with one term. Binomial, bicycle means two wheels, two terms. Trinomial, three wheels, tricycle, and it means three terms. So right there, that's an example of a binomial because there's two terms. This down here, 3x squared plus x plus 3 is a trinomial. There's three terms. They are all considered polynomials, but they have specific names for the number of terms they have. If you go above 3, we just call it a polynomial. We don't really deal too much with the specific name. There might be one, but I don't know what it is. All right, first question here is polynomial has, which of the following are monomials? Remember, monomials are one term. All right, and they have to be in the form AXN sometimes. We just have to make sure that all my rules are followed. All right, so for A is a monomial. This is a single term. The exponent is a non-negative integer, so I don't see anything wrong with A, so that's cool. B is a polynomial, but is a binomial. There's two terms, so it's not it. C cannot be a polynomial because it has a variable in the denominator. So it can't be a monomial, it can't be a polynomial because of that. Now D is a monomial, and that's okay. There's a single term. It doesn't have to have a variable. So the fact that it doesn't have a variable doesn't bother me. E is not a polynomial, so it cannot be a monomial because of the negative exponent. Remember, the exponent has to be a non-negative integer. So if it's negative, it's not it. Going down here we want to find if it is a polynomial, and if so, what's the degree? Well, I don't see anything wrong with 2. The 3x squared is fine, the 4 is fine, the negative 2x to the 5th is fine. So I think this is all a polynomial. I don't see anything wrong with it. And then remember, the degree is the highest exponent. Well, my highest exponent is that 5. So I only had really two options, 5 and 2, so it's got to be 5. 3 isn't a polynomial. My first hint was the x under the square root. Can't have that, makes it not a polynomial. And we also have a variable in a denominator. Can't have that, not a polynomial. So 4, there's nothing I see that makes it not a polynomial. And so it is. And now I got to look for the highest exponent. Well, the biggest exponent, which is my degree, is 7. All right, moving on down. We're going to do questions 5 and 6. Write the polynomial in descending order. All right, now what descending order means is we're talking about the exponents. So we're looking for the biggest exponent and put it first, and then the next biggest exponent, and they keep getting smaller as we go down. We are not paying attention to the coefficients. All right, so 5. The biggest exponent is 12x to the ninth. So I get that, and I write it first. I look for the next biggest exponent, and I bring the sign with it. It was a negative, so I got to bring that negative. Negative 2x to the fifth. And I look for the next biggest exponent, which would be cubed. I am not paying attention to the coefficients. Obviously, negative 25 is the biggest coefficient. That could go first, but we're not doing that, right? It's exponents. We got to pay attention to the exponents. I will do the same thing as 6. I'm looking for the biggest exponent, which is at 12. All right, then I look for the next one, which is going to be 8. I'm bringing that negative 44, right? The negative sign with it. Don't drop a negative. Easy way to lose a point. Then next number is cubed. And if you look at each one, the exponents are going down smaller. So that's the important piece here, is that the exponents are in descending order, meaning going down, going smaller. Finish that off. And then the constants are always last because they have an exponent of 0. All right, now 7. We're going to be talking a little bit about closure. Okay, yeah, then over here, I'm going to talk about we're not paying attention to the coefficients, which I already said, right? Descending order is talking about exponents. All right, closure. Example of what closure means is if 2 humans have a baby, right? Me and my wife have a baby. My 3-month-old is a human, right? So 2 humans have a baby, you get a human. An example of not closure, of something that wouldn't be closed, if my wife and I had a baby and we had a squid or a koala bear or whatever other species or other animal. All right, that would not be closure. So closure is the idea is if you have things that are similar characteristics and they operate in some way, the result is that same thing. So for a polynomial, if we add 2 polynomials, we will get a polynomial answer guaranteed. There's no way for us to add polynomials and the result not be a polynomial. So that's closure. So basically I have a bucket of polynomials. I grab 2 out, add them together. My answer's inside the bucket. All right, now which operations are polynomials closed? It's easy. It's all of them except division. So addition, subtraction, multiplication. If you add, subtract, or multiply 2 polynomials or 3 polynomials or whatever, if you do that, your answer will be a polynomial every time. All right, so if you add, subtract, or multiply, your answer is going to be a polynomial if you use polynomials. Division just won't work because there's a potential. Now, you could divide 2 polynomials and get a polynomial answer. That's perfect. That's 100% okay. That does happen. But there are also scenarios where you do it and you don't get a polynomial answer. All right, so here we divide this. There's a variable in the denominator that makes it not a polynomial, not an answer. So, straightforward. All right, next one is the area of rectangular patio is 4x squared, right? Which makes sense because the length is 4x, the width is x. I find area of a rectangle by multiplying length times width. 4x times x is 4x squared. We build a square garden. Looks like an area of 9, right? Because 3 times 3. The garden is 4x squared plus 9. That's the total area of the patio and the garden. All right. What does the constant term in the polynomial 4x squared plus 9 represent? Well, the constant term, they tell us, is the 9. The constant term just means there's no variable. All right, so it would have no variable with it. And we already talked about it. 9 is the area of the garden, right? We knew it was a 3 by 3 garden. We had already talked about the area of a square or rectangle's length times width. So you do 3 times 3. Coefficient, all right, we talked about coefficient already, and they remind us it's the number in front of the variable, the number that's multiplying. So in this case, it's 4. And for this scenario, the 4 is just saying that the length of the patio is 4 times as much as the width. So the length is 4 times bigger than the width for the patio. That's all really the 4 is telling us. Yep. So length of the patio is 4 times as much as the width.